Hello, my name is Nenye Abraham and I want to welcome you to my YouTube channel. Now we have started a new lesson in mathematics called calculus. In our first lesson, we did introduction to calculus. We learned about some of the types of calculus, divisions of calculus, and divisions in calculus. We also learned about limits of polynomial functions. And today we are looking at limits of rational functions, and we shall solve some of the examples. Now, in the limits of polynomial functions, we learned that limit where x is approaching a is just substituting directly the value a into the function in place of what, x. Now the same thing applies here. The only difference here is that the function given is no more a polynomial function but a rational function. Now what is a rational function? A function f(x) is said to be a rational function if it can be expressed as the quotient of two polynomials in x. And we know what polynomials are. Now quotient just means that it could be what, multiplication or division. So when it is multiplication or division, two functions multiplying each other or dividing each other, then we say it becomes a rational function. It becomes a rational function. Now let's look at some of these things. Now limit where x is approaching infinity, of a function. For example, having a over infinity sign, it is equals to 0. The answer is 0. Now lim where x is approaching 0 of a function like this. Now a over 0 is infinity. These are some of the things I want you to keep in your head, so that as we continue, you enjoy and appreciate what we are doing here. Please do subscribe to my channel if you haven't, and press or turn on the notification bell to be notified whenever I release a new video. Then limit approaching 0 limit where x approaches 0 when you have a function like this, then this is equal to what, 0. This is equal to 0. So please, I want you to get this clear before we continue. This is 0. So for example, we are solving examples. Now we understood what polynomial functions rational functions are. We understood what rational functions are. We also understood some of the constant solutions we had in the rational functions concerning limits, or when it comes to limits. Now we are going to look at some of the examples and their solutions in limit. Example 1, find the limiting values of a. We have limit where x approaches 2 of the function. We have 2x minus 2 all over x minus 1. If you are given a question like this, and we learned that when you have something like this, what you need to do is substitute 2 in place of x in the function. So when we substitute 2 in place of x, but before we substitute 2, you realize that in the numerator we can factorize 2 out, and so it will be 2x minus 1 all over x minus 1. Now this can take away this, and you are going to get 2. So this will give us this. That is for our A. That is for our A. Now let's look at B. Let's look at B. We have limit where x approaches 1. X squared plus 1 all over 2x cubed minus 1. So let's substitute 1 in place of x. We are going to get 1 squared plus 1 all over 2 times 1 cubed minus 1. And this is equal to 1 squared is the same as 1. 1 plus 1 is 2. This will be 2 minus 1, which will give us 1, and the answer is equal to 2. The answer is equal to 2. Now there are example 2. Find the limiting values of these questions. And it's 4 questions. We have A, we have limit x squared minus 4 all over x minus 2 where x approaches 2. Now this, if you substitute 2 inside, you realize that you have 0. It is not even 0, it's 0 over 0, which is undefined. So what you do is that you factorize this thing. You factorize the numerator. When you factorize the numerator is difference of 2 squares. What makes it difference of 2 squares? If you rewrite this thing like this becomes difference of 2 squares, which can be written as x minus 2 x plus 2 all over x minus 2. And it can now be written as limit where x approaches to x minus 2 x plus 2 all over x minus 2. This can take away this, and this will be lim where x approaches to x plus 2. And what is your x? Your x is equal to 2. So you substitute 2 in place of x in the function, and you get 2 plus 2, which is equal to 4. And this is the limiting value of the function given A. Now B, example B, we have lim where x approaches 3 x minus 3 all over x squared minus 5 x minus 6. We call this the denominator quadratic. The denominator is quadratic. So if you substitute this straight, you're going to get what? 0 over what? 0, which will be undefined. So what you do is that you factorize the denominator before you can substitute the what? 3 in place of x. So when you substitute when you factorize the denominator, you will have, so factorizing, this is what you get. Factors of what? Factors of 6 minus 6. It's a quadratic. Factors of minus 6, that if you add, you get what? Minus 5. X minus 5. If you multiply, you get minus 6. And that is what? 1, positive 1 and what? Minus 6. And so this will be it. Factorizing this, you're going to get, factorize this to be like this. So factorize what? X out, you get x minus 6 plus x minus 6, and this will be x plus 1 x minus 6. So we are getting lim x minus 3 all over x plus 1 x minus 6, where x approaches 3. So doing this, we can now substitute what? Our what? Limit inside, which will give us what? 3 minus 3 all over 3 plus 1 multiplied by 3 minus 6, and this is equal to 0 over 4 times minus 3 minus 12. And we've learned from the beginning of the rational functions that when you have 0 over something, 0 over something is equal to 0. So 0 over this, which is equal to 0. Please, I will end here for this lesson. And please, my name is Nenyi Abraham once again. Please subscribe to my YouTube channel if today is your first time of coming across it. And also turn on the notification bell so that you'll be notified whenever I release a new video. In the next lesson, I will solve more of the examples under the rational function example, especially the when the limit is approaching an infinity sign. Thank you very much. Stay in touch.